A logarithm is the inverse of an exponential function. Evaluate logarithms. Let b and y be positive numbers with b not equal to 1. The logarithm of y with base b is denoted by log base b of y and is defined as follows. You can see it right there. Just a reminder of how to read it properly. So since an exponential function is the inverse of a log, we could write one in one form and the other form. So for example, if I say that 5 to the second power equals 25, I can rewrite that as a logarithm, or just log for short, and I would write it as log base 5, so it's a subscript there, of 25 equals 2. So you could just remember that as 5 to the second power equals 25. A common logarithm is a log with base 10. So you're never going to see, usually you're not going to see written log base 10. You're just going to see the word log, and you need to know that means log base 10. And then there's also a natural logarithm, which is a logarithm with base e. And again, you're usually not going to see something written as log base e. It's just going to be written as ln. And there's both of these have a key or location on the calculator somewhere. Quick thing about ln, usually when you read it, you will say natural log or natural logarithm. You're allowed to say ln once you've said natural logarithm 1,000 times. That's the rule. Example, rewrite each into exponential form. So if you look at the first one, we have log base 2 of 16 equals 4. So I wrote it on the side here, and if you make an arrow like this, it may help you out. Then you can see that 2 to the 4th power equals 16. That's it for that one. For the second one, same thing. Make an arrow. So I can rewrite it in exponential form as 4 to the 0 power equals 1. Next one, log base 9 of 9 equals 1. Make the arrow. So 9 to the first power equals 9. And last one, we have log base 1/5 of 25 equals -2. So we're just rewriting it. So 1/5 to the -2 power equals 25. And if you apply your exponential properties, 1/5 to the -2 power is really just 5 squared, which is how you get to 25. Next example, evaluate the logarithm. So log base 3 of 81. We want to know, what does that equal? So what I could do is rewrite it as an exponent to help me. 3 to what power equals 81. So it's 3 times 3 times 3 times 3. Therefore the answer is 4. So final answer, 4. You could also use your calculator. If you have a TI-84, go to math and scroll all the way down, and if your calculator has that key log base, you can type in log base 3 of 81 and see what it equals. Next one, log base 4 of 0.25. All right, Don't change anything up. So we want to know, what does that equal? So 4 to what power equals 0.25, or I could even say 1/4. Well, 4 and 1/4 are reciprocals of each other. Therefore, the answer is -1. 4 to the -1 power equals 0.25. And you could check it both ways. Log base 1/6 of 36. Okay? So 1/6. You notice with logs, usually a fraction is written going diagonally, just to not confuse things. All right, so we need something to make it a reciprocal, so therefore we know there has to be a negative. And then you just have to ask yourself, 6 to what power would give you 36, and it's 2. So log base 1/6 of 36 equals -2. And last one, log base 27 of 3 equals what? So 27 to what exponent equals 3? All right, it's got to be something that made the number smaller. Recall that if you took the cube root of 27, you would get 3. So to write cube root as a exponent, that's 1/3. So that's the answer. Since logarithms and exponential functions are inverses, it follows that if you substitute one into the other and vice versa, you will always end up with x, which you get started out with. So using that, we can use that property to simplify something like example 3. So first part A, simplify 10 to the power of log of 9.6. Well, if you don't see how to use the property, we could rewrite it like we did before. And then we will see that actually the property does in fact work out. So if I wrote it as 10 to the power of log 9.6, and that equals something. And I'm going to call that something u. All right, first, because that log doesn't have a base written, we know that it's base 10. All right, so this exponent I could write as a log. So try to follow this. So therefore I would have log base 10 of u, and that would equal log base 10 of 9.6. And the reason I could do this is because I could take this 10, raise it to this entire part on the right side, and that would give me u. All right, but if you look at it again, I basically have log base 10 on both sides and two different numbers. So therefore, u has to equal 9.6. And go ahead and verify with the calculator, and you could also just use this property over here. So my final answer is 9.6. Part B, simplify log base 7 of 49 to the 2x power. Okay, again, I can use this property here But let's say, what if you forgot the property? Then I can say that, let's say all of this is together, just to help me out. And I can change the 49, because in order to use that property, notice that you need to have the same base here, hold on, in both locations, as you see there in green. So when I rewrite this, I have log base 7 of 7 squared, because I want these numbers to be the same, and then that's raised to the 2x power. All right, let's add some parentheses to make it a little bit easier. All right, we can simplify what's in here, because we have a power raised to an exponent, so we keep the base and we multiply the exponents. So now we have log base 7 of 7 to the 4x power, and all that is going to equal something. So if I rewrite it as 7 to what power equals 7 to the 4x power, the answer has to be 4x. So therefore, final answer is 4x.